Topic 1.5, Applications of Logarithms. We're going to cover half-life, life, light, pH, decibels, and magnitude. So, here are some timestamps, as usual. Now, let's take a look at this question. We are first given the half-life. Sorry, this should be C. Anyways, we're first given the half-life. It's 560 years. The half-life is how much time it takes for half of the matter of an atom to not be in it or not exist. Well, I'm not a chemist, so I wouldn't know how deep it goes. Anyways, let's find the rate of change at which the material of the carbon leaves. So let's write x to the power 560 is going to be equal to 1/2. Now we can solve our x. We know it's our base. So we can rewrite x as x equals, and there we have our x. Now we want to find when it's 3/4 as much. Basically, when x times something is going to be equal to 3/4. So we know that n will actually be, well, of course n is the number of years, it's going to be log of whatever x was over 2 3/4. So we're going to get 1/2, 1/560, 3/4. Now this is as simple as plugging into the calculator. Which is going to be 2,390. So it's going to take roughly 2,390 years. Now let's look at this question. We're comparing the magnitude on the Richter scale. Magnitude can be defined as such: log intensity and our reference intensity. This reference intensity is a constant, but let's not worry about that. Let's write both magnitudes with their respective intensities and this reference intensity. When we write magnitude 2 minus m1, we're going to end up getting a really interesting situation. Minus I1 over I0. Now, if we put this in one large equation, we're going to end up with this over I1, I0. The I0s cancel out, which is going to be log I2 over I1. I2 over I1 is going to be 10 to the power of m2 minus m1, which is 0.8. We can calculate that real quick, and we're going to get 6.309. So it's going to be 6.309 times more intense for the second earthquake. Now let's calculate the pH of a swimming pool with a hydrogen ion concentration of 6.21 times 10 to the power negative 8. We know pH is going to be equal to negative log of whatever concentration we have. And it's going to be 6.21 times 10 negative 8 mole per liter. This can be identified as can be identified as 7.207 pH. Now let's look at the second final question. So for this one, we're given light intensity is 4.2. We can just write it down immediately. And this is just a simple logarithm question. You know our logarithm, which is 1 minus 0.13x, is going to be equal to log our base 10. We can just write log here, and 4.2, which is our anti-logarithm. So 0.13x is going to be 1 minus log 4.2. So x equals 1 minus log 4.2 over 0.13. What is it? 1 minus log 4.2 divided by 0.13. It's going to be roughly 2.898 meters. This is the depth that the aquatic plants need. Now, let's look at this question. This is pretty similar to the magnitude one, except the formula for loudness is in decibels. Sorry. It's in decibels, which is going to be dB is going to be equal to 10 log I1 over I0. dB2 is going to be equal to 10 log I2 over I0. Now we can just compare it the same way. dB2 minus dB1 is actually just going to be 10 log. And we had the same formula we can use. It's just going to be I2 over I1. Now then, what's really interesting is we can take this 10 and put it over here. So we get 10 to the power of 9 over 10 is going to be equal to I2 over I1, which is going to be equal to 10 root 9 10 power 9 over 10, 7.943. So that means the louder snore is going to be 7.943 times louder.